Hi, I'm Mike Harvey. I'm here to talk to you today about the Prius plug-in hybrid conversion. This is a kit that was originally developed by CalCars as an open source project and has been subsequently enhanced with the help of Plug-in Supply, Petaluma, California. This is a custom install we did for Mr. John Nicklin, and I'd like to give you a little tour of it. So it all starts with a basic Prius. What we do is we add a battery pack of lithium iron phosphate cells, in this case 80 cells at 3.2 volts per cell. At 40 amp hours is about 10.2 kilowatts of additional power. It is roughly 5 times the onboard power of the OEM battery, which sits here. So this is the additional battery that we add. It is one string of 80 cells in this case, each with its own battery management module, which talks to the BMS controller here. So this nominal voltage of this is about 265 volts at charge, and what that does is it supplements the OEM battery while driving. And then we communicate between two boards. One is a rear control board and one front control board. The rear control board, if you come over here, controls two contactors here, which provide supplemental charge to the OEM battery, which sits back there. That's a nickel metal hydride battery, about 2.2 kilowatts in capacity. So on board we have roughly 12.5 in total. So the rear board basically opens and closes the contactors on request from the front control board, which also talks to the CAN, the car access network, or communication for all the vehicle stuff. We tie the BMS into the CAN bus as well, and I'll show you a little bit more about that when we get to the front. The BMS can be monitored additionally by this DB9 cable, which basically plugs into the serial port on a computer, and you launched Elithion Lithium 8 Pro software. This is a Elithion Lithium 8 Pro BMS, which controls the charging and discharging, high limit, low limit, and basically monitors the state of the pack as we're driving. We also have an onboard 12 volt power supply here, which basically provides 12 volt DC when the car's plugged in and sitting and charging. And there's a 3 amp or 3.5 amp charger back here. It is a CCCV, constant current continuous voltage charger that we use, and it's controlled by the BMS and turns on and off to basically balance the pack during the charge cycle. These cells charge to 3.5 volts. As I said earlier, the nominal capacity is 3.2, so that is by manufacturer specs. These are CALB 40 amp hour lithium iron phosphate cells. It is a brand new pack and it is running like a top. To access the cells, we built a custom lid for this. We just removed these two screws and the whole plexiglass top lifts up. All of the control components are accessible by this board, which basically just slides in and out. So if you ever need to service anything on the control board, you can get to it. We also have on here, we have a source current sensor, which basically monitors the current of the charge. So how much current we're putting into the batteries when we're charging, as well as a load sensor, which is in line here, which basically monitors how much we're pulling out of the pack while we're driving, and displays in the front. So that's basically the back of the car. Incidentally, all of this stuff is removable, so the car can be reversed and sold or resold or reverted to a normal Prius at any point in time. It is very unintrusive installation. This car also has more sturdier shocks in the back because this is about 300 pounds of additional weight. And you can see the charger plug here. This is a 110 charger port. We could put a J1772 on here, but since the charger only supports 110, we don't for this case. You may upgrade in the future to a 220 charger, which will give them a bit of a faster charge. So that's the rear. Go to the front of the car. There's some things of note here that we add based on our own experience. first off, the enable button to turn on the system is here. It's lit when the system is enabled. And now the PHEV system is on. And in the off state, it runs just like a normal Prius. There's a kill switch here, which basically disables the fuel pump and forces the car into EV mode only. The car will get about 30 miles in EV range in all EV mode. I have the exact same system in my car, and I hardly ever use it because it will drain the OEM battery down if the aftermarket pack is too low, and then you have to turn the car off and back on to re-enable the fuel pump. So I don't particularly use it, but on a short trip, if you're going to 7-Eleven, 5-10 miles round trip, you can force it into EV and not use any gas. Over here, we've added, this is a Samsung Galaxy Tab 2 running Torque Pro application, which we have customized the interface of to give us, some statistics, cell voltage, min, average, and max for each cell in the pack, cell temperature, and resistance of all the cells, same min, average, and max. The entire pack voltage, which goes up and down depending on whether or not the contactors are charging the OEM battery. This is the OEM battery voltage, so you can see one, and you can see state of charge of each. This is a countdown depth of discharge, so it starts at 0 and then counts down up to 40. You probably never want to do 40. You probably want to go to about 32 would be about as far as you want to go for length of the pack. This is current, so this is as I said earlier, we have a load sensor, which basically tells us how much current we're pulling out of the pack. At any given point in time, this can go up to a couple hundred amps. This is our instant MPG. This goes up as high as 300 MPG, and we have an RPM gauge here because the car doesn't necessarily have one. It's good to know if you want to drive more efficiently, what your RPMs are. Up here is your stock consumption monitor and energy monitor, just so you can actually see how the car is doing. This is the OEM battery pack level. That's capacity of the pack, not necessarily voltage, so we'll correlate to SOC. Fully charged, when it's all green bars here, is roughly 65 there. About 15 amp hours out of 40 depleted on the drive. But we got 98 miles to the gallon coming here on a 22-mile trip. Under 35 miles an hour, it's always going to revert back. But that was our efficiency coming here, 98 mpg, which is roughly double what the car gets normally. And it will be over 90 on the return trip, and the pack will be probably depleted to about 30 amp hours. As I said, it's a relatively new pack. Things to bear in mind: watch the minimum voltage. You will receive a low limit light which says one of the batteries is below what we set is the lowest capacity of the cell, and we set that at 2.8. It's very conservative. The cells can go down to 2.5, but that's not good for the cells over the long haul, so we set it at 2.8. When that light goes on, this should be probably about 2.7, at which point you probably want to turn the aftermarket pack off, just to protect the batteries. Right now you'll see it kind of toggling, and that's because the front board basically spoofs and sends a bunch of trick messages out on the CAN bus to fake the car into thinking that it's overcharged, in which case it's always going to opt to burn off the electric first, and that's how we get the efficiency that we get. So an overcharged OEM battery, the car will revert to electric mode and drive primarily on electric with only gas supplementing. So that's how fundamentally it works. The downside of that is you get a lot of noise on the CAN bus with the front board turned on, so you'll see it toggling between 2.2, 2.1 and 2.3, and that's basically the spoof noise, and it basically just broadcast blasts a bunch of noise on the CAN bus, and it's next to impossible to filter out, but you get used to it after looking. You know what a real number is. So 3.3 is the actual minimum voltage as of now. There's a solar panel on the roof, which was added by the owner, Mr. Nicklin, That's no longer available, unfortunately, but it isn't very efficient, but it does actually trickle charge the aftermarket pack as it's sitting. So state of charge, that's another one. That's the PHEV pack. It starts at 100%, and as it goes down, it depletes. This number is actually not very accurate, only because it'll change as the demand on the car changes. So when the contactors are engaged and we're charging the OEM battery, this thing will go lower and go higher. So it's a rough indicator, not an exact indicator, and because of the noise, tends to be less useful than we want. The real gauge is the PHEV DOD. That tells you how far down you have drained the PHEV pack. So that's one to watch. MPG is one to watch, and obviously these mins. When that gets to about 270, you want to stop. There's a fault light, which is a BMS indicator. All of these are indicators from the BMS. Fault basically says there's something wrong. Typically you hit a high limit, which means cells are over the limit of 3.6 or under the limit of 2.8. That will come on intermittently while driving, only because of sag. So when this min cell gets around 3 and then it engages, it can drop to 2.7, in which case you'll probably see a fault light. If the low limit stays on, that means you have one cell or more than one cell that is below the limit, and you should probably turn the pack off. High limit you should hardly ever see while driving, but it's there. The BMS will protect the pack from that typically happening, but we leave it. Source power basically says we're regenning. We're getting some power back that typically will come from regenerative braking or coasting down a hill, or in case where the engine is spinning off power, which does happen in a Prius from time to time. So it will engage the engine, and it will spin off current to reduce the pack. So you'll see that it's on right now, actually, which is kind of interesting. The coolant is important because the car will not operate as efficiently if the engine temperature, the coolant temperature, is below normal. So you'll see when you start to drive, your efficiency will be a lot lower, and once the car warms up, it'll be a lot higher. Not really an issue in the spring and summer and fall months, but in the winter months, you'll notice a significant difference. Fuel used is an estimate. This is a half a gallon I used in a 20-mile trip. I'm not really thrilled with that number. I don't think that it's calculated right. But again, these are some of the canned PIDs from Torque Pro, and we use them as our. But it is a decent indicator. So 20-mile trip, use a half a gallon. That's not right at 98 miles to the gallon. So this is a suspect number. 3.5 amps. At about 250 to 260 volts, so a reasonably decent extension cord. 12 gauge or better is probably recommended here. From empty, or from about 20% DOD and down, will take a good 8 to 9 to 10 hours to charge. So it is a drive it during the day and plug it in at night type situation. As I said, that charge is probably a little underpowered for this, but it did come with the original plug-in supply kit, and that is definitely a candidate for upgrade in the future for J1772, which is public charging, port charging standard, 220 volts with probably a high capacity quick charge to reduce the charging current. That's about it for now. Thanks for listening. Happy driving.